Welcome to decision theory and mathematical models. The objective of this session is, at the end of the session, you will be able to identify what is decision theory, what all mathematical models of decision theory are there, and how to solve decision mathematical models. In the first part, we will be dealing with introduction to decision theory and mathematical models. Okay, let's start. What is decision theory? Basically, decision theory is an analytical approach in which a body of knowledge is used to assist in making choices from a set of alternatives in view of their possible consequences. How can we do it? We can do it with the help of a mathematical model, which is an abstract description of a concrete system using mathematical concepts and language. What are the types of mathematical models? Basically, there are two types of mathematical models. First one is deterministic model. Here we assume all data is known with certainty. And the second one is the stochastic model. What is the stochastic model? It explicitly represents uncertain data via random variables or stochastic processes. Deterministic models involve actually optimization. So we do optimization with the help of deterministic models where the data is known with certainty. And stochastic models, with the help of stochastic models, it characterize or estimate system performance. The deterministic models are linear programming, network optimization, integer programming, nonlinear programming, inventory models. And what are the stochastic models? They may be discrete time Markov chains, continuous time Markov chains, queuing theory, waiting lines, decision analysis, and game theory. These are the examples. There are many more. And simulation also. So, again, decision theory represents a general approach to decision making which is suitable for a wide range of management decisions, including capacity planning, location planning, product mix problems, product and service design problems, equipment selection, credit policies. So these are some of the examples where decision theory can be used. But we can use decision theory in many other problems as well. Okay, let's see how a problem is formulated. A decision problem is characterized by decision alternatives, states of nature, and resulting payoff. So these are three things, basic three things, which basically form a problem. What are they? Alternatives, states of nature, and resulting payoffs. Okay, they are, first of all, decision alternatives. They are the different possible strategies the decision maker can employ. So, how many possible strategies are there? These all are decision alternatives. And what are the states of nature? They refer to future events not under the control of decision maker, which will ultimately affect decision results. So states of nature are basically future events, natural future events. And states of nature should be defined so that they are mutually exclusive and contain all possible future events that could affect the results of all potential decisions. So what is the third one now? It is the payoff. The consequence resulting from a specific combination of a decision alternative and a state of nature is a payoff. So, the combination of an alternative and a state of nature, it basically ends up to a payoff. A table showing payoffs for all combinations of decision alternatives and states of nature is a payoff table. So, payoff can be expressed in terms of profit, cost, time, distance, or any other appropriate measure. Generally, we are dealing with these four terms: profit, cost, time, and distance. This is the payoff table. We can see that we have decision alternatives, we have states of nature, and we have payoffs. What are decision alternatives? Courses of action or strategies. So, what are states of nature? An occurrence over which decision makers have no control. And payoffs, quantitative measure of outcome. So, these three things should be there to formulate a decision problem. Let's take an example. Okay, very simple example. We have to make an omelette of 3 eggs. Very simple problem. You may be encountering it in your daily life. You are preparing a 3-egg omelette, having already broken 2 good eggs into the pan. You have broken 2 eggs into the pan. You are suddenly assailed by doubts about the quality of the third one. You are unsure about the quality of the third one. You are not knowing whether the third one is a good egg or a bad egg or a rotten egg. As yet, unbroken egg, 2 things may happen. Either the egg is good or it is rotten. Definitely, there are only 2 possibilities. So, what is the payoff table over here? You can make payoff table like this: egg omelette broken. We have events, we have probabilities, and we have you can see in the left column we have third egg is good and third egg is rotten. There are only 2 possibilities which are out of your control, because as they are out of your control, so they are states of nature, and we have probability assigned to it that third egg is good, it is 0.9, and third egg is rotten, it is 0.1. And if you break third egg, what will be the result? The result will be either you break third egg into the pan, or you break third egg into saucer and inspect first in a separate saucer, or you just throw away third egg. You can do that. These are the acts or strategies you can adopt to check the third egg. Either you drop the third egg in the same pan. Number 2, you take a separate saucer and drop that egg, break that egg into that saucer and inspect it. And third one, throw away the third egg. So, what will be the outcomes then? What will be the payoffs then? If the third egg is good and you have broken third egg into the pan, so you end up with 3-egg omelette. It is good, very nice. Then, if you have broken third egg into the saucer, again you will get a 3-egg omelette, but you have to wash 1 additional saucer, isn't it? Then, what is the third one? Throw away third egg. Means 2-egg omelette. You will get only 2-egg omelette. 1 good egg will be destroyed. It had probability of 0.9 and you have destroyed it only due to doubt. So, you will get 3. So, these are the payoffs if the third egg is good. Okay, coming to the next possibility when third egg is rotten. Then, if you drop it into the same pan, oh no, your all the 3 eggs wasted. No egg omelette. 2 good eggs destroyed. So, this is the risk. Okay, so this is called a risk. Then, again 2-egg omelette, 1 saucer to wash when you have a separate saucer and you have dropped it. You get 2 eggs omelette and 1 saucer to wash, and you have to throw away the third egg because it is rotten. And if you have thrown away the third egg, then 2-egg omelette, you have done the good, right? So these are, so in this way we formulate our problem in the form of payoff tables. We have states of nature, we have strategies or alternatives, and we have payoffs. Okay. Now, decisions can be made under 3 conditions, under 3 environments. One is certainty, second is risk, third is uncertainty. In the previous example, we have seen a possibility of risk, right? You were not certain, you were uncertain about the third act, right? So certainty is environment in which relevant parameters have known values. You know exactly what is there. If you know exactly in the previous example that the third egg is rotten, so it means you will be doing your decision with certainty. But what is risk? Environment in which certain future events have probable outcomes, which we did in the last example. Uncertainty, environment in which it is impossible to assess the likelihood of various future events. So there is uncertainty, all right? So these are decision environments. Okay, what is next? If we are doing under the environments of risk, we must have a decision for which the outcome is not known with certainty, right? Okay, we can list all possible outcomes and assign probabilities to the outcomes. So when we are dealing a problem with risk, we have to assign certain probabilities associated to it, all of the alternatives. What is uncertainty? Cannot list all possible outcomes because we are uncertain about it. So even we cannot list all the possible outcomes. So cannot assign probabilities to the outcome. If all the outcomes are not listed, how can we assign their probability? So risk and uncertainty are two different ways of doing a problem, right? When we are dealing with certainty, it is an environment in which future outcomes or state of nature are known. For example, EHP, analytical hierarchical process, we will study that, will be dealt in next lecture. Examples are investment in bank, fixed deposit. There is certainty regarding future payment or maturity. So this is basically certainty environment. And when investment in share, you are having risky environment because you are unsure. And investment in shares fetching returns higher than fixed deposit, basically you are playing now. Okay, in other 2 years it is uncertain. You are not certain in next 2 years whether we are alive or what will be the market conditions. So these are uncertain conditions. So these are 3 examples of uncertainty, certainty, and the risk. So this is end of part 1, which was for the introduction of this problem solving and decision making part. So we will be meeting in the second part of the video, inshallah. Thank you.